we wanted to do this one today. I think a lot of guys that are on this phone call, we have either I, myself, Chad, or Shane have spoken to personally over the last year and have seen some of our dashboards and stuff like that. So we're not going to go real deep feature heavy on SmartPAD, although we are going to show the dashboards. We're going to give an update and talk about the product itself. But this first webinar is going to be centered around the discussion around the remote access, our operating system, and how it's enabling a lot of our current clients to maintain remote access, keep people in their shacks, separate people, but still share all the data and actually use it as an operating system in real time to facilitate that. And then we are actually going to show some screen flots because we are releasing a version 4 dashboard next month. That's going to be a complete new dashboard, new redesign. And a lot of the direction of the new dashboard has been that Cold Bore is very unique in that we are an operating system, only one that digitizes frac trees and tracks ops time. So there's a lot of draw from our clients that they want to use us for that. But we understand there are competitive companies out there that are software as a service companies, Kelvin, Corva, Well Data, like that. Those are SaaS companies. And we're going to kind of talk about the difference between us and them on this call, and the fact that we do have a lot of clients that will see 1 or 2 features in their SaaS company, even if they want our operating system, and how we've taken those ideas, developed them, and now we're integrating them into one complete package and offering the same feature sets that a lot of them have, which I think is, one of the biggest focuses for our clients. And when they speak, we listen. They say, we would like to have this from that client, and bring it all into one. So we'll show you a preview of the new dashboard with all those new features, frac action, and all the stuff that's going to be released at the end of this month. And then the invite will be extended in probably a couple of weeks. We're going to do a follow-up webinar with the brand new dashboard with all the features we're going to cover. And at that point, we are happy to go over anything else in more detail as well. Sorry, Chad.
Hey, Brett, I think you just covered what I was going to say. I don't know if you guys have seen, Brett's been doing a YouTube channel, just getting kicked off again. So I think he's getting used to this. You better keep going, Brett. You just covered everything I was going to say.
Sorry, buddy. Sorry. Yeah.
So that's okay. Brett's going to be sharing the demo page just so you can kind of drive and navigate through that. But basically going to identify the problem in the industry. A unique solution right now is because of the problem, and our solution to that problem is we have the ability to almost remotely connect all of the services on a site to help with the current situation of keeping social distancing on site. So that's just one of the inherent benefits or advantages of SmartPAD at the moment that's kind of reared its head.
Great. So is there, I do want to throw a question out at the start of this. Is there anything else aside from, we're going to talk about a quick revision of the SmartPAD, what the current functionalities are with our commercial clients out there. We are working for 15 current clients, super majors and medium, mid-size, mostly anyone with a multi-well pad. We're going to cover that. We're going to cover COVID, remote or social distancing and remote access, and why our operating system is different than the software as a service companies. And then the features that we are pulling into our operating system so that we can come to the market with one integrated operation and not have our operators need to go to different places to get different features. Okay, so we're going to start. I think one of the probably the most asked questions that we get is, what is the difference between Cold Bore and the SaaS companies? And let me just define what I mean by SaaS companies when we say this. Obviously, the problem we're talking about here today, we pretty much all share a common understanding that the problem is operators need remote access. This is well understood. Everyone in the market knows it for the last 3 or 4 years. Completions needs to catch up to drilling in terms of getting remote access and visibility and control on the operation. And a lot of people have kind of flooded into that space to try and solve this problem for the operators. And we just want to separate some of the noise and give our perspective on where we think everyone is shaking out right now. So common understanding that your system has to do. We need to be able to remote into location, right? And I think this is where the conversation tends to steer in terms of like, yeah, we can throw a Raspberry Pi or some type of connection device out into any one of your services, into your frac van, into your wireline, into your pump down, whatever it is, and we'll bring that data back. And then the conversation kind of gets off into the weeds about the user interfaces and, you know, analytics and all that type of stuff. And where our discussion, we've had to learn this through the last 6 or 8 months of talking with operators too, and what the real issue is here, is that's kind of table stakes at this point, right? I mean, it's no longer really a unique selling point that we can pull back, you know, data from your different service companies. Although we are one of, I think, like 2 that are actually doing it for any digital output. So we don't care if it's frac or coil or wireline or pump down. We're doing offset well. We're hooking up with fiber connections with some of our clients now on their SmartPADs. We're working with all the big service companies in terms of moving all this data into databases. So we have a very integrated approach because our motto is to become the universal centralized operating system that all service companies and operators plug into and communicate on. So inherently, it has to be able to connect everyone's data and show it all in one place. So we show all frac data, all wireline, all coil, all pump down. So that aspect alone, we are, in our opinion, we are leading the group in connectivity. Some other companies have focused more on the analytics side, and they had really great analytics platforms. Now, the issue with going down that road is that the main problem is not actually the connectivity or the analytics or the visualization of all this data, right? Those are problems, and the solutions that have come to market do help. There's no doubt. But the real problem is data quality. And so the biggest issue is that operators, when other service companies, when you adopt the technology from a straight SaaS company, they're throwing these Raspberry Pis or whatever they are into the service companies and pulling all their data back and then displaying it for you. The trouble from an operator's perspective is that's a very service-centric approach. And the operator has no control over how that data was captured, right? So the data that's coming back and being displayed on one pad may be captured really well, on the next pad not so well, on the next pad mediocre. You never know. But the problem, that is the problem. You never know, and there's a variance to it. So no matter how good the visualizations are at that point, or how smart the artificial intelligence is, or if there's machine learning or all these words that everyone throws out, you're missing data in certain spots, and or it's incomplete or variable data. So the issue becomes you have all these really fancy screens with graphs and so forth, and you're looking at all this data, but from one pad to the next, everything's changing and you're not sure why. So you're not sure if that's a 10% variance in your pad, the actual operation, or if that variance is due to data acquisition. And so the first step in this digital evolution of completions was definitely, let's just get connected, right? Let's get visualized. I need to see frac. I need to see coil and all that stuff. What we realized at Colbor, and we went down a lot harder, longer road than most of these guys. We've been at this for 7 years now. We're 20 million in. And it's been, you know, a lot of people have challenged us along the way and said, you're going to do a service company, a software company, and you're going to develop hardware to outfit the frac trees. Like, that's a nightmare. You should just do the service and then connect people and show analytics. That was good first step. But what the industry is well aware of now is the inability to control the data collection and the lack of those systems' ability to connect automated equipment. Like from our service companies, Halliburton and FMC, Cameron, NOV, we're working with all of them because they all have digital frac trees, digital accumulators, automated pumping units. But all these individual companies from an operator perspective cannot connect all that equipment to make the operation cohesive. You need a centralized operating system, right? And so going down that road, what we realized is there's a lot of benefits to this, but the absolute must is that we get control of how the data is collected on site before it's sent anywhere. So before we take it and move it outside of the frac van up to the operator's eyes, we need to make sure that that data is right. So how do we do that? We can't, you know, Colbor can't put someone in all the services. They're not going to allow it. The operator can't put more people on location. That gets too expensive. So the way to do it is you have to have a data set to compare all the service data sets to be able to check, to make sure that they're right. And so the way to do that is to digitize the source of the operation, and that's the frac tree, right? So the purpose of digitizing frac trees, aside from safety and visibility and all that stuff, is to draw data from those frac trees through our algorithm that we built that does what we call state detection. So because we have valve position sensors and pressure sensors that our guys outfit on any old wellhead, we turn them into a digital asset. We look at it at Colbor like another service company, right? So you got coil, you got wireline, you got pump down. Now we have the service company, which is a digital frac tree. That's the source of the operation. So one of the biggest problems with this is if you're going to try to normalize data and be able to check all the services to make sure they're doing it right, which timestamp and which data do we use as the right one, right? Do we use frac's timestamp and then try to correlate wireline and pump down to that? How do we know they're right? Right? And it becomes this arbitrary discussion. So the philosophy behind Colbor's system is we have a unique data set that we generate. And that data set is the time series data that's coming from the frac tree, right? So we're tracking when frac starts and stops, when wireline starts and stops. We're tracking well swap, well switch, and we're tracking greasing. Any of the major operations, the time series data is being tracked automatically now. So that is the first foundational data set that Colbor does that nobody else does. Because to do that, you need to have a service company, you need to outfit the wellheads with sensors, and it's just a lot of work. But we now realize the benefit of that. When we have that time series data tracked down to the second, we've now relieved the company man of having to write that down in his notebook, right? So we're no longer relying on a company man to say 10 o'clock to 11 o'clock, 11:30. So I'll show you the data that we generate for the time series. But what we do as Colbor now is we take that time series and say the frac tree was ready to go at 10:01, and we started fracking at 10:04. And then we fracked all the way to 11:37. And we can compare the frac tree data to the service data to make sure that that's correct, QCing data before it leaves location. So I'm going to show you guys some of our screens here on the new dashboard. And I'll go through some of the functionality so that we get some context of what I'm talking about. And then we'll talk about what this means on the backside for automated analytics, automated databasing, automated reports, really a reduction in your infrastructure and a freeing of the time of your men on location. So what this does is this turns a really laborious analog job into a highly assisted, automated assisted software system that allows the productivity of the men that you do have on location to go through the roof, and also to reduce infrastructure and people that have to touch and manage data throughout your organization. So I'm just going to show you this because this is our next dashboard that's coming out end of the month. And then I'll go back through and I'm just going to use this one for time purposes because we want to keep it to 30 minutes today. So we're going to do it.
Here, Brett.
What's that?
I'm just going to piggyback on some things you said here.
Sure.
Just recently, we've had a lot of requests here for, cleaner data, usable data, and that's come up from a science pad that one of our clients is doing. So science pad, you all know what that means. You've invested a lot of money. In this case, it's some fiber going into a well. The offset well monitoring data, the importance of the timestamp that we generate and having everything stitched to it is even more important on these science pads, where you want to see a response within seconds, even milliseconds, not 10 seconds. You're not questioning whether the response on your offset well was 5 seconds later or 10 seconds later. You know exactly what that response time was. So the value of the common timestamp is really rearing its head in these science pads. And another thing is, I think we're future-proofed with this system. We're going to start to see thousands of sensors on a frac site, on a completion site. And you as a client, you probably know you don't want to be opening 10 different platform windows to view this. You're going to need a central operating system. So I would call SmartPAD the future-proofed solution as well.
Yeah, so a great analogy is that on the drilling side, we had Pason and RigSense, basically, that came out and released EDRs 15 years ago. Their job is just to they set a computer in the rig that's gathering all the data from the rig, and it's visualizing what's important to the driller and it's throwing this into a database, whatever's left into a database. I was in the field for 10 years, and I use those EDRs all the time. We would never consider drilling a well without one now. On the completion side, it evolved without that. So the biggest problem on completions is when it started, we were just fracking one well at a time. And so every service company was already digital, right? We had digital everything. On drilling, when Pason and RigSense were released, there was no digital in the 90s, really. So they created the digital system, and everybody used WITS-ML, right? And so there's a format in drilling. With completions, when it started 15, 20 years ago, there was digital around the world, but completions had no digital centralized operating system. So the frac company, the wireline company, and everybody digitized and put sensors on their own stuff to some degree. And the problem that created for the operator was that it turned into a very service-centric approach where everyone's worrying about themselves. Frac worries about frac data, coil worries about coil, and pump down worries about pump down. But there's been no evolution in this system for 15 years. As the operation itself has evolved massively, we've gone from fracking one well to zipper fracks. Sometimes we've been on 14 or 18 well pads where you've got services tripping all over each other with really complicated operating procedures and processes that need to be tracked down to the second. But we're typically still relying on notebooks to track the time series data. And then we're getting all kinds of different data sets in from all the services that have two problems. They're all different format, and they all have a different timestamp. So this creates a massive infrastructure drain to try to correlate this data, to make sense of it, to employ people to put it into Spotfire, to employ another person to move it into your databases. And it renders a lot of the data largely unusable. So Colbor's attack point to this market is that we're dropping a centralized edge server onto location with hardware that digitizes frac trees to create a unique data set, which is going to be our timestamp, right, of the operations, i.e., we're creating a format. So because we can't go out and force all the services to change and now adopt a WITS 2, I don't think that's the right approach. It just won't work. People are too entrenched in how they do things right now. We need to create a format and then have an edge server on location that everyone hardlines into as a service. And then we can drop all of that 1 second service data into the right columns before we move it off to have the operator have access to it. And what that does now is that creates an operator-centric approach, saying, as an operator and a human, I need to be able to look at my operation, all my data sets in relativity to each other, and have them in the context of a timestamp. So I know what's going on between frac and coil, or wireline and pump down, and be able to consume that easily. But more importantly, the user interfaces are great for us, and that's what we use on the fly. But for after the fact, I need all this data to be normalized. So I don't, as an operator, don't really care if it's Halliburton or Schlumberger or Liberty or I don't care. I have an operation that has frac, coil, wireline, and pump down. I need all the data organized per second and then dropped off in my database so I can query it with automated systems to send out automated reports, to draw analytics, to use on the fly, to have a mobile version. That's all doable. But to do that, the key is you have to digitize the frac trees so that frac tree can pull the time series data and use the timestamp from the source of the operation. So we're using a GPS timestamp at the source, which is the wellhead, which is no service company's opinion. That's when the operation happened. And so as we work with Halliburton and Schlumberger for all of our clients right now, they ask us, well, which timestamp and how do we line up timestamps? It's all going to be lined up to the GPS clock that's hooked up to the frac trees. And so every second of every day, we have categorized from the start to the end of the frac. And we take all the service data into our edge server and we line it up. So each second has coil, wireline, frac, pump down, all the raw values, and so on and so forth. And what it is, we end up with an operating system that everyone has access to. And the operator controls who can see what. They tell us, and we give access based on permissions. We lock stuff out, or we don't show them certain things. And we end up with a format, the Colbor time series format, that all raw service data is in. So that's going from the service-centric approach to the operator-centric approach. And all kinds of efficiencies come out of this. So I'll show you some of the screens that give you an idea of what I'm talking about for those who haven't seen this. This is the new dashboard that's coming out end of this month. You may have seen one before. I'll just touch on this. This is the dashboard that's currently running in the field with a lot of our with all of our clients. So down here, you have all of the time series data. So the bottom third of the screen here, this is called our critical path on our current dashboard, and I'll show you how we changed it. These blocks here, so you see well A, B, C, and D, the swim lanes that we call them, this is just time moving from left to right. And if you hover over any of these blocks, it'll tell you what block of time and operation that was in real life. And wireline is blue, frac is colored green, black is standby, and gray blocks are greasing, well switch, well swap, stuff like that. On here, we have the algorithm that's automatically detecting what operation is happening. So it knows frac was 10:15 to 11:36. This is very important from an accuracy standpoint. Accuracy is how we are now defining the return on investment to our operators in a really quick fashion. So we have all these things that this system can affect. Safety, productivity, we're saying we can look at it, we can do valve position, we can connect automated systems, FMC in them we're working with now, digital frac trees, digital accumulators with automated lockouts so we never cut wireline again. We want all that connected and plugged into what? FMC doesn't build these systems. So we plug it into our operating system and we can see that. Same thing with Halliburton's automated equipment and so on and so forth. There's a lot of value that you can go down a million different paths about how this is going to change the business, but how do we get a return on investment calculation immediately? And the easiest way to do that is with the accuracy of your time series data. So when we move from recording in notebooks, typically there's 5 or 15-minute increments for most operators, and they say frac is 10 o'clock to 10:30 or 10:35 even. But really, it was 9:57 to 10:56. So we lost, 5 or 6 minutes, 3 on each side of that one block of operation. We might have 40 of those blocks a day, right? And so you add that up and it adds, typically on most of our pads for our clients, that invisible lost time in improvement in accuracy runs between an hour to 3 hours per day. And if you you connect that to your AFE on the back end, it might vary from $7,000 to $10,000 an hour per operator. That might be coming down quite a bit right now, but it's quite a bit of money. So if you're saving 20 minutes a day or half hour a day, then our system is paid for, and then everything else on the back end is free. The rest of our custom software development, all the analytics, it's just a way to look at it, I guess. So down here, this is the time series data that nobody else has. This is unique to Colbor. We have a patent filed around it about how we do state detection with all the sensors. This is our data set. So, and this is now what we use to compare to all of the other data sets that are coming in real time on the edge. So you'll see here that this is frac data. We can hover over any of these raw values that are coming in. We don't mess or touch the data that's raw. We leave it. The key is that we take that raw data, and you'll see here that our frac block, if we hover over it, it'll tell us this was stage 17, and it was 9:13 to 10:56. So it was an hour and 43-minute long operation. And we're going to verify it because the data from the raw values or the raw data is stitched to line up to the operational data. So now you have 2 independent data sets that you can bounce back and forth to check. And we have that with all your offset well pressures. We have offset well equipment that we set off as well. We've done up to, I think it's been 18 different offset wells. All those data sets, typically when you have a communication event of some sort, you've got your operational data from the frac that you have someone inside your company looking at, and then you have your offset well data, and they're going to try to find these events, and that can be quite laborious. We have automated event detection, and so that when that happens and we see a spike on an offset well, that data is grabbed, 5 seconds of that data or whatever it is, there's a marker put in, and it's stitched to the frac data that's automatically here, so we know exactly what happened. We can quickly pull a report on that. Wireline and pump down data. We overlay this for a lot of our clients. Currently, all these graphs, you can just zoom in and it'll move the time series data and the raw data, and analytics and so on and so forth. So that's the current screen that's running. I'm going to run through these really quick and try not to get too long-winded here. So on the V4 dashboard, we're pretty excited about this. We spent a long time and most of our money getting the foundation in place to be able to gather the time series data and do all this. Now we're moving into really feature-rich stuff. We want empirical frac stages, and we want to be able to take old frac stages and overlay the current frac stage. So we can look at deltas. We want to set flags, align ISIP. That's the type of feature-rich stuff that we're able to turn out now because we've got the foundation in place. So the way that we'll log into the new dashboard is through, we'll have a GPS function. This is really just kind of a cool feature. We had requests from this in Midland. Some companies, and again, it's different for everybody, get up in the morning and have trouble. They're like, I got to find my equipment. Did it move last night? Did it move yesterday? Where is it? Because we're connected to satellites, it's easy for us just to make a geomap and tag where the different frac crews are. These, obviously, we have an operator here that has 4, 7, 10 different frac fleets running, which might be a little, that might be a little presumptuous at this point. But let's say they had 10 frac fleets running. If they have 7 of them connected with SmartPADs, then they're showing up on the map. The other 3 would just be blue dots that they cannot track because they have 3 that are not connected to SmartPAD. When you click on this SmartPAD logo, that's what brings you into all the dashboards, and it opens up all your service data and your time series data. So these are the new dashboards. You'll notice that we moved the third of the screen here that we were using for the critical path, because initially when we were thinking about that critical path, we were saying the value is going to be in tying the time series operational data to all the raw data, which it still is, but that's mostly for a database thing so that it is properly organized. What we realized is that we can move, visually our clients in the field weren't using all of those lines all the time. They really only wanted to see the operational timeline for the well they were on. And then they wanted a summary page if they did want to go look at all the wells all at once. So the new dashboard design allows full utilization of the screen for raw data and much more intricate functionality in terms of zooming, panning, moving, and exporting data so that they can do on-the-fly analysis. So I would say that we rival anyone else, Corva or any of the internal frac systems in terms of functionality in the new dashboards. These 2 toolboxes on the side, these are standard, these are global for the system. So you can hide both of these and get full screen for your graphs. If you pop them out, these are fully customizable. You can turn on and off any one of the raw data lines that it's coming in on the fly. So pressure, rate, sand concentration, totals, fluids, FR, anything. You want to set values, max and mins. You do all that here in your toolbox and then you hide it. On this side, this is showing you the actual digital readout for those. Now, this is all frac data. You can see at the top of your screen, you have the frac indicator. The same screen will be for wireline, for pump down, for coil, for offset, and so on and so forth. And then here at the top, you see that this is well D. So this is your timeline of operations on well D. And the same thing applies. Wireline is blue, this glowy green is frac, and the dark shaded ones are NPT. Anything with a red square around it is UTF. That's unable to frac. So we have 3 data sets. The first data set that we're separating is the algorithm determining what operation is happening all the time, 24/7. The second data set is when frac goes from PT to NPT and back and forth. And then the third data set is when any of the NPTs, so if wireline is continually incurring an NPT, that's fine. We want to be able to see that, summarize, grab report, handle it. But when that wireline incurring NPT starts to daisy chain and then causes frac to be held up from moving in, now that's a separate data set. That's UTF. That's unable to frac, because the wirelines weren't a problem until it started costing us money. We need to know when these were a problem, and now someone's responsible for costing us money. So we have very well thought out data architecture in terms of the time series data and how that's represented. And then the top line here is a summary of, so whatever service you're on, the algorithm will determine that. It'll say, I'm going to go to my frac screen. The algorithm will know well D or well A or well C is under frac, and it'll automatically pull up that well. It shows you that well's timeline, and then it shows you the summary timeline for the service company. So here's where we fracked, A, B, D, E. So that's the individual service screens. Again, we have the well overviews. All this data, all service data, all operational time series data, all frac tree data, valve position in 1% increments, open, closed, everything is recorded and stored indefinitely. So you'll be able to go back and replay every one of your pads from start to finish. This is a wireline and pump down screen. So we've overlaid the data for you. Again, looks a lot like the frac, the functionality. We've kept everything a global design so that it's easy for us to learn, train. And with a lot of our clients, the implementation and the end game, the end state of this is that there's no cold bore people on location as an end state. Cold bore guys are necessary early on because we have to digitize a lot of the manual processes. We have to ingest everything that each individual operator is doing, identify and build their processes into the software, right? So software of cold bore's SmartPAD doesn't really change from a logic perspective, but we know that every operator has different conventions, naming conventions, categories, and subcategories. So we customize that to them and we map the algorithm to their physical processes on location so that it's detecting properly. So that's the first step of the cold bore guys being on location. And then as a field guy for 10 years, I knew the second critical step is adoption. We don't drop this off and ask your company man or your engineers or anyone to say, figure this out and learn how to use it. Because until they understand the value, they don't have any incentive to want to learn something new. They're just trying to get their job done and spud by 6. I used to get stuff dropped off all the time before I knew what value it was providing myself. Each individual person provides the company man value, engineer, VPs, and I would just lose interest in it and throw it out the door. And now the whole system is for naught. So cold bore, when we're out there, we hook this thing up and we're running it. It's a great opportunity for us because we run it in parallel. We provide access to all these user interfaces. And, but by the time the first pad or the second pad's running, we're taking all this data under time series format and putting it into your database automatically. That's the hook for the company man on location to say, here, why don't we just move all this for you? You don't have to spend an hour per stage per day anymore doing this. Just hit yes and accept every time the algorithm detects something, check it and accept it, check it and accept it, and it's gone. Once we get that, we have critical adoption on site. And cold bore is as responsible for that as any operator to make sure that we are doing what it takes to get this implemented properly for our clients. So at that point, whenever that is, 5-6 pads in, it's an integrated system. It takes some time to get this up and running. But once that happens, cold bore can move to a rig sensor, a PaySol model, where we just come out, hook stuff up, turn on the edge server, everyone plugs in. We manage it from our 24-hour support center. So we have an RTOC that has 50 screens in it, and we're supporting all our clients. We can see all their screens. If anything goes wrong, we're helping them fix it 24 hours a day. That's how it's going to be. We're going to operate that model, and we're going to provide the software in the future. Right now, we help with the onboarding, we help with the digitization, and we do all the custom dev. So there's the pump down. This is just now we've moved the critical path to its own screen. That's a nice summary. This gives you a little bit of analytics on the fly on the side here. It tells you what operation is happening where. There's a visual. You can break it down by well. You can break it down by pad. You can break it down by zone, multi-well, whatever you want to do. So the data, once we have it collected properly, and that's in the database, whatever we ask it for, I need a report on frac for these 2 wells or these 4. I need a summary on how my NPT was for these 3 or this. I need to compare my services. It's all doable, and those are all just views that we're going to build. But they come from the normalized database, and that's the key to being able to do this quickly and efficiently. Now, this is what we're talking about. Some of the features coming from some of our competition. I won't say names because I don't want to dive in that far, but we do have clients that say, well, we love that you're an operating system. We love the safety aspect. We love the time series. We love all that. But they have this feature where they take empirical stage data for frac and they allow you to set flags on it and then overlay the live stage that's happening and line up all the data. Let's say we want to line everything up to ISIP, or we want to line everything to breakdown pressure, and we want to look at it in real time, make some adjustments to our FRR pressure and see what the reaction is. So that's what frac action is. And that's this screen here. I'm pretty excited to show this one at the end of the month. We're testing it now in the field. This is all live. We just have screen grabs for you guys today. We don't love showing testing environment stuff because that always bites you in the ass. But so right here, you'd be able to go select which well 1, 2, or 3. I want to change the y-axis, but I want stage 1, stage 4, stage 17, let's say. So it will graph stage 1, 4, and 17 or 19 or whatever your selections are up to 3 stages. And then when you hit show live data, it ghosts all those lines. So you see how there's gray lines in the background there, and this is your live data coming in over top. So as you are running each one of these stages, initially your men get to set the flags and say, here's our breakdown pressure, here's the ISIP. You'll see these flags up here because, as we all know, every frac stage is different in length. So that means that the important events are going to be at different intervals. So we need the capability to say, grab all my ISIPs, whether the frac was that long or this long, line them all up so I can see exactly what I'm looking at. Our software does that automatically. And while your guys are setting them for each individual company, we see their preferences. We have machine learning in the background recording all this, and eventually we'll get to a point where this is just automated. We have a light version in case some of the screens are hard to see outside. And then probably one of the biggest selling features that I'm excited about that a lot of our clients have been asking for is in the next 6 weeks too, we're going to be releasing the first alpha full mobile access. So we're going to be able to get on the phones, and along with mobile access, so we get the wellhead views, we get the frac data, the coil, the wireline. We are starting off with the wellhead and the chat functionality. So oh, I see a thing coming in here. So what mobile is going to bring is the ability to have communication in system. I think this is critical because right now a lot of our operators are using WebEx and phone and text, and we have them telling us, can you just build a chat function inside of mobile so that whenever people are talking back and forth and sending pictures or whatever, it's all stitched in via timestamp to the same operation that is on the dashboard. So that comes with mobile. And of course, that's just going to expand from there. We'll start out with a certain base data set on mobile, or functionality set, sorry, and then we'll just continue expanding. We have a long line of requests from, I want to see flags, I want to see alerts and alarms. I want it to notify me when I'm over pressure. I want a notification when we have an NPT incurred. All of those are going to be adjustable per client. Maybe I don't want to see all the NPTs. And do I have to acknowledge them? Does my company man have to clear these on location before we move, before he is alerts all disappear off his phone? And then I get an audit trail of what's been cleared and what's been done. Right. And then equal to the mobile coming up here is our increased analytics platform. This is going to look a lot like Spotfire for guys that are familiar with using Spotfire. Again, our whole move is, I think we went the right path. We spent the money to get the right data and have the right system. It was a lot of work. But now we're working on features to integrate all the stuff that everybody wants from other competitive products into one house, so that we eliminate the multi-vendor software problem for our clients. So you're looking here, NPT by vendor, NPT duration. These are all visualizations that are going to run in real time. So they'll adjust as the operation's happening, and they don't require anyone to touch this data. This just goes. And you don't need to pay for a separate analytics platform anymore. So these will also be what drives the reporting. From this is the same data that we're going to grab automated reports from, and that'll be by operator. Say, here's how we look at our morning report, here's the afternoon, so on and so forth. So again, a lot of increased functionality coming out with the new dashboard that we're really excited about, and just to think a little cleaner, more high-tech look. That, and I guess I kind of skipped over to touch on the COVID thing. Obviously, we need to find a way to have better access to run our operations remotely. A lot of that, there's kind of two elements to that. Automated equipment is one. So a lot of the equipment providers are working furiously on that. We've talked with FMC. We're currently talking with them, and Cameron, Halliburton, all these guys. They all have different products that are automated in their own sense. And now there's just a requirement for a centralized operating system to connect it all. And we're focused pretty heavily on that. But immediately today, until that transpires, the ability to see all this data for our clients, men in the field, means they don't have to be moving into the frac van. I don't need to walk over to wireline. I don't need to go check on this. So we can keep them all separate. So from a safety standpoint, I think there's a lot of incentive to move to something where we have an abundance of data like this. And that's really about it for me. I think I'll run it there. We ran a little bit over, but I did want to leave it open for some questions if anybody had some questions on that. Don't be shy. You always want some questions at the end of it so you don't feel like the dickhead.
Hey, Brett,
Yeah, Mike?
Yeah, this is Michael Bihonik with Apache, so I won't leave you hanging.
Thanks, buddy.
Okay. Curiosity in the use of this from a standpoint of, has anyone looked at it for contract management? or KPIs on performance in regards to that, because the data is a lot higher fidelity.
Yeah. So I love that you go there. We've thought the design and the background of this, we thought that through right through to smart contracts when we get there. So just contract management as a first start. You're talking this level of accuracy on the time series data is what allows us to move to really, really scrutinous performance-based contracts. And that's a win-win for everybody. That doesn't mean we're going to roast any services. It just means that it's going to be precisely what it was. And we're going to pay and subtract based on any credit debits that were monitored. Right. And so it's always a 3-step process, Mike, when we go from analog to automated. And so right now we're analog and we're in the augmented stage. So it goes analog, augmented, automated. We're in augmented right now, where we're assisting more than we're automated. And where we'll get is, since we're using the algorithm to automatically track the operations now, that's all 1 second accuracy. That's a really great improvement, and it's non-biased. This isn't us cold bore recording it. This is, saying that it's not a service company. It's not the operator. It's just sensor data. And it's being displayed so that both the operator and the service company can see it. And so when they have any disputes or any communication that wants to happen, that can happen in platform in real time. We can extract that data to populate contracts, right? But what I see happening in the near future here, and we're having discussions with some of the more tech forward operators now, is what we want to do is build digital pumping plans that are in accordance with the format of our system. So everyone has a pumping plan right now. We want to digitize that and increase the accuracy of that pumping plan, or the expected accuracy of that pumping plan. So when we build a cold bore pumping plan, we'll set it in the background of the system here. That gives us an expected. And then this system is tracking the actual. So what we get is an expected versus actual, and the system automatically pulling out any differences, saying we should have been an hour on this wireline. We were an hour and 20. And we can run a report that grabs all the deltas that were missed in that operation. And that can make up the discussion for how we need to change and adjust the contracts. The last evolutionary step of that is building I don't want to get overly technical here or boring, but a Hyperledger based smart contract. All that is a piece of software that says, we've written it to say, transact this when you've had certain approvals. And so all we need to do is implement a dual handshake in the system, because we have the expected, we have the actuals, we have the differences tracked to 1 second. Now we allow access from Halliburton, Schlumberger, any of those guys to talk to you on this system and say, hey, this block right here, we're 23 minutes over. Here's all the raw data to support it. Are you good on that? Yeah, we're good. Okay, check, approve. Now that automated contract could hold all those in waiting until the operator says transact.
Very good. Have you seen, with the higher fidelity data, my last question is that, has it been, for some of the folks who've done this, who may have a real-time center, has this really helped with the real-time center and helping with decision-making? Because in completions, it's been other than in a passive sense, hasn't been very interactive and helping the on-site folks, especially the company men.
Yeah. Yes. So the RTOCs, when we start putting this in, so the companies that have the more advanced RTOCs now, the real key here is the correlation of the time series data, right? Because bringing raw data back is one thing. Like we can infer things from raw data. But when we have data to compare it against, we now know in real high accuracy, said like, well, why were we 7 minutes over or 3 minutes over on that well swap? Well, how do you know we were? Well, because the valves on the frac tree were waiting. The frac tree was ready to go at 10:57, and we didn't frac until 11. Why that 3 minutes there? Were they pressure testing? Were they greasing? Like, what was it? And you're communicating on the fly, right? And so it's that level of accuracy that's happening because of the visibility and because of the opposing data sets. So as humans, we can compare the two back and forth. That goes for wireline, that goes for fracking, well swaps, whatever it is. That level of understanding is what's really changing habits inside of RTOCs for guys to be much more actively managing their fracs like this.
Just another point on that, Brett. We focus a lot on frac data when we're talking about RTOCs, but some clients are seeing value, definitely looking back and saying, okay, the pump down guys traditionally didn't know what the wireline guys are doing. So when they're running in, they're trying to keep in that safe operating window for that plug, that frac plug, and some wireline units are being, kind of almost caught running in too fast over the safe operating window, and then presetting plugs. So the real time isn't just a value in frac. We're seeing other services be able to view other services, key services that they weren't able to real time view before. So now a pump down guy and a wireline guy will have each other's screen in their cabs and be able to view what they're doing.
Yeah, to that point too. I mean, we're moving into a world here where it's not just individually pulling back data for display. This is enterprise level software so that multinational companies can plug into this and have as much access and functionality as the operator. And that's where we all see a really big win, right? When everyone starts conversing and using the same system, we've created a format, we've created a standard, and we've created something that looks the same, Mike, for all your operations. It doesn't matter who or what service or what pad. You could switch everybody out. You turn that pad back on tomorrow. It's going to look the exact same for your guys. They're going to track it the same way, see the same data, and it's just going to have a different name in the metadata. And that's where we really start to be able to dial guys up in operations, reduce the infrastructure, and polish this process with just full transparency on everything. Anybody else? Any other questions while we're still on here?
API tie-in to operator in-house software, planning, daily reporting, field cost tracking, etc.
Okay, so REST API we're developing right now. That's ready for this release here. So that is the next step in more sophisticated data transfer. Right now, we've been kind of bridging a gap for operators where we allow export to CSV or just moving data however they want to see it, and we're assisting them in getting that data and moving it. Our API is finished end of this month. So a REST API means we have a certain format for our daily reports, summaries, frac reports, all that stuff. We can plug in, connect the API to the operator, and that's going to automatically move. The field costing, that's something that, again, is tied back to the time series data and then backed up by the raw data. So you use the time series data to put that in your X value in the equation, and then you take your dollar value and you get your result. You back that up with the raw data. How they want to see and execute on that field costing mechanism, we haven't actually built that for anybody yet. But again, I see how that plays out. And that's, I think, depending on how sophisticated what they're looking for and actually paying or moving, if they just want to track field costs, that's actually pretty easy. We build an equation sheet with a user interface and we'll have it spit out costs. Again, that would be a special request. Part of what we do is that the custom development of software and requests comes with our package. That's built into a day rate. So that would be something that we add on. What was the other part of that question, Daph?
Sorry, I'll just read it out again. So API tie into operator in-house software, planning, daily reporting, field cost tracking. Yeah,
so that's it. API is there, planning, so pump plans, they're all manual, they're all analog right now. So like I said, I'd love to get to a point where we're developing digital pumping plans to put into the system so we can track against them. That's coming up right away. And then the field costing would be something that would be when each operator asks for it, we'll move to that and start producing. That's just basically another report.
Yeah, and we also have the ability to map your well view or open wells hit list, I guess, and then our nodes meet your nodes, and that automatically transacts into your reporting.
Okay.
Further that daily reporting, we have one client right now that has in their contract, if the frac provider is 10 minutes over, even on well swaps, it goes into MPT time. So to get that level of accuracy, we require the resolution of SmartPAD, and they're really appreciating all the post work that doesn't need to be done as they had to do last year. So they used to spend, 30 minutes or 30 days after the frac was complete, they're still arguing over minutes in the contract, and that's been swiped away from them. So they're freeing up a lot of time, both the service and the operator.
Yeah, once we get to the contracts that Mike was talking about, and we will reduce infrastructure inside and completely. This will change the business model for large oil companies because we're getting this automated data from the field and we're moving it through directly to the APAR side of the business. The whole account management discussion negotiation thing doesn't happen post frac. It's happening on the fly, so that all those people you need for account managers and running around negotiating and phone calls, and this goes on to another desk and another desk, we can pare that down probably drastically. I don't know how yet, but it'll be a drastic reduction in infrastructure. but that's it. I'll wind it up there. We don't want to overdraw too long. Our next podcast is when we have the SmartPAD V4 out running and ready to go. We're going to click through and show all the functionality. We're going to go through frac action, and we're going to show you guys this in real time. So thank you very, very much, everybody, for jumping on. And I hope this was informative, at least for you guys. And if you have any questions, please just shoot an email to Chad, myself, or Daphne, or anyone, and we'll be back to you soon.